Dear students, very good afternoon. Today topic is overview of classification of signals and system. Our first unit title is classification of signals and system. Before we are going to classify the signals and the systems, everyone should know the definition of signal. What is signal? Now I will explain the definition of signal with a suitable example. See the slide. I have given the photograph of a classroom. Before that, everyone should know what is the difference between independent variable as well as dependent variable. The variable that is not changed by other variable you are going to measure. Such variables are called as independent variables. For example, I want to measure the temperature of this room. First, you should know whether the temperature of a room throughout the area is constant or not. For example, at the door side or the window side, at the entrance, the temperature of this room is different. It means that with respect to space, the temperature of the room varies. We know the unit of the space is measured by meter. 1 meter equivalent to 100 centimeter. You agreed. We know with the help of temperature, with the help of pressure, we can't change the 1 meter equivalent to greater than 100 centimeter or less than 100 centimeter. Therefore, we can say the meter is an independent variable. That is, this unit of space is meter. So, space is one of the independent variables. The next one, we want to measure the temperature of this room throughout the day. With respect to time, we can measure the temperature of this room. For example, morning 9 a.m. you can measure the temperature. Then 10 a.m. you can measure the temperature. As we know, during the daytime the temperature increases. When the night time goes, the temperature of this room decreases. So with respect to time, the temperature of the room varies. So from this example, I want to conclude that with respect to time, the temperature of the room varies. Another one, with respect to space, the temperature of the room varies. So the temperature varies with respect to time and space. Therefore, we can say the temperature is one of an example of the dependent variable. That is a physical quantity you are going to measure. Then I have given two independent variables for the definition of the signal. First one space, then another one is time. So the unit of time is second. We know that. So 1 minute equivalent to 60 seconds. With the help of pressure or with the help of heating, you can't change the term. That is the 1 minute equal to greater than 60 seconds or 1 minute is less than 60 seconds. So therefore we can say the examples of independent variables are space, time, etc. Now we are going to conclude the definition of signal. Signal is a physical quantity like temperature that varies with respect to independent variable such as time, space, etc. So as per the definition given in your textbook, I have concluded the definition just now. So what are the examples of a signal in real time example? We can say in real time example of a signal, electrocardiogram, EEG signal, the noise in an electrical circuit or electronic circuit, telephone signal, text, data. So many examples we have with respect to the real time. I have given the ECG signal image for your proper understanding. The example of a signal. Another one, EEG signal image. This is the example of the data. The next one, this is an example of image. This is the number plate of a car. But if you want to do a project in signal processing, this definition will not support you to complete your project. So if you want to do a project in signals and system, you should know the proper definition of a signal. I will explain with the help of the green board or a blackboard which support to enhance or to complete your project in signals and system area. So let me consider this blackboard image. If you see this blackboard image, you are getting two inferences. One is the black color, another one is the wood reaper. We know for what purpose we made the blackboard. For writing purpose. On which area utilized for writing purposes? We know the black area. So I want to tell you the important thing related to signals and system or digital signal processing. The signal comprises of frequency components. In all signals we have two kinds of frequency components, namely low frequency components, another one is high frequency components. First, as an electronics and communication engineer, you should be able to identify where the low frequency components are exist in a signal, similarly where the high frequency components are exist in a signal. From this blackboard example, you will able to identify the proper signal definition which support to enhance your research or practical related works. See, I want to say the low frequency component always carries the original information or wanted information. The high frequency component, we have two types of high frequency component. One kind of high frequency components always gives protection to the low frequency component as well as provide security or it lies the surrounding of low frequency component. All the low frequency components are covered or protected or secured by the high frequency component. So from this example, I want to conclude where the low frequency component is present. We know the blackboard is only made for writing purposes. So therefore, the black color area refers the low frequency components. So the low frequency components, I said, covered or protected or secured by high frequency component. Therefore, the wooden area or the wood reaper area is referred as the high frequency component. I said two types of high frequency component we have it. One is a good frequency component which provides security or protection to the low frequency component. We know the low frequency component only carries original information or wanted information. So it lies at the edges. So at the edges we have the frequency component. Such components are called as high frequency component. The next one, another type of high frequency component which lies along with the low frequency component. The group of frequency component gives disturbances to the low frequency component. Such frequency component is also called as high frequency component. This high frequency component present along with our low frequency component. For example, before writing this blackboard, what will be the appearance of the blackboard is good. Once I write something on this blackboard, what will be the appearance? It's very worst, or the appearance is degrades when we consider before writing anything in the blackboard, isn't it? So for example, this is my blackboard. So before writing it looks good, looks nice. So after writing something, what will be the appearance of this blackboard? It's degraded. So I said one group of high frequency component present along with low frequency component. Therefore we can say this white area is low frequency component. This border of this blackboard or whiteboard, that is the edges, are referred as high frequency component. Then another one, the letters which are written in the inside this box is also called as high frequency component. So as an electronics and communication engineer, you should concentrate how to eliminate the removal of noise or how to avoid or how to extract our original or required frequency component from a signal. I said a signal comprises of both high frequency component and low frequency component. The low frequency component always carries original information. The two kinds of high frequency component we have it in a signal. One kind of high frequency component provides the security to the low frequency component which lies at the edges of the signal. Then another one group of high frequency component which present along with low frequency component. Those frequency component gives disturbance to our low frequency component. For example, see, this is my number plate. So from this number plate we identified that on white area only we have written the black letters and we have some blue color shaded part. So from this number plate we identified that the white area is referred as low frequency component. Suppose we want to extract the numbers which were written in the white area A111 AA. So we want to extract the A, that is the number which were written in the number plate. So we want to apply the high pass filtering algorithm, signal processing algorithm to extract the number plate. So our objective is we want to extract the number plate. So in this example we want to extract the high frequency component from the signal. So in practical approach, I hope you all understood the practical approach which will enhance your research work or practical work if you want to do any project in future. Thank you for giving me this opportunity. Thank you, dear students. If you have any doubts, clarify with me. Thank you.